I'm greeting you in our framework of our project of challenges of source evaluation in science and correlated areas. So, dear Professor Strevens, I have several questions for you, and let's ask me my first question. What place does philosophy occupy in science today? Why is an attitude towards psychology today as an abstract and unnecessary science, especially in the common man? And how does this threaten society?
Well, the position of philosophy is, as you say, on the outside looking in. So philosophers of science, like me, are very interested in the way science works, but we're very much not a part of it. And in fact, philosophy has been, I think, exiled from science for a few hundred years, since the scientific revolution, really, which is not necessarily a bad thing. I think the kernel of science, the kind of the engine that makes it work, is a commitment to arguing, to making a case for or against various theories, entirely using empirical evidence, as opposed to, for example, philosophical argument. So in the reasoning of science, the argument of science, the logic of science, if you like, philosophy has been entirely pushed aside. And that's turned out to work very well. Of course, I love philosophy. I don't mean to disparage it, but the scientists focusing 100% of their time and energy and attention on empirical evidence as opposed to philosophical argument, or for that matter, religious argument, theological argument, or anything like that, has turned out to be very productive. So it's been a good thing for philosophy to step back. Now, as a kind of a side effect of that, if you like, well, more than a side effect, but an additional effect, philosophy has tended to be pushed out of science education altogether. And so although there are, of course, some scientists who are very philosophical, the average scientist is not like that at all, which I think can be a good thing in some ways, although it's also a bad thing in some ways. So it's a good thing because it helps scientists to do what they're supposed to do, which is to focus on the evidence and not to get carried away thinking about philosophical coherence or harmony or big ideas. On the other hand, it does mean that in their thinking generally, they can tend to be somewhat narrower. So to return to the way you led off the question, which is, what's the place of philosophy? And I guess you might say, how can philosophy help science? And in what ways can we help science better? The answer is, I think, we do have to operate from the outside, but we can help science in two ways, we philosophers of science, I mean. First, by helping scientists themselves understand better why they do science the way that they do, including the exclusion of philosophy from scientific journals and so on. And second, we can help science by educating the general public and showing them, explaining to them why science has the peculiarities that it does, the features that it does, in some ways, the irrationalities, partialities, biases, prejudices, arguments, a kind of a obvious lack of agreement in many ways, at least about anything that's actively being researched. We can explain to the general public why science has these aspects and that this is the way it's supposed to be. This is science working as it should work, rather than a sign that science is degenerating, out of control, or has been taken over by special interests. So for example, I'll just give you one example. The science of climate change has, of course, attracted some skeptics from the outside, motivated not perhaps entirely by purely objective concerns, but then who is? And those skeptics have been able to point to internal arguments within climate science, a kind of sometimes even slightly Machiavellian strategizing about how to shine the spotlight on the evidence that best supports certain views while leaving certain other kinds of evidence in the gloom. And to somebody who has a picture of science as an arena of perfect rationality and objectivity, this looks horrifying. And when critics of climate science from the outside say, look, science is not objective, it's scientists have views and they're doing whatever they can to advance those views, that can be very harmful if the general public is expecting this kind of rationality and objectivity. What we as philosophers can do is explain that although science is rational and objective in some ways, you shouldn't expect this kind of simple, straightforward agreement on theories and on what the evidence shows about theories. So we can help science. We can help science from protect science from a kind of general mistrust or skepticism.
How would you describe the logic and psychology of science today?
So the interesting thing about science, and this is going to follow on directly from what I was just talking about, is that although I think the general public and even many scientists, when they're not looking very closely at what they themselves are doing, although they expect science to have a kind of a logic that at least to a considerable extent tells scientists how to interpret evidence. So it tells you what kinds of evidence count in favor of some particular theory and what kinds of evidence count against. What looks like a set, what would be a set of measurements that shows you that the Earth is indeed on average warming, to go back to the climate change example. So people expect science to be regimented by the same kind of logic as, say, mathematics, where mathematicians all agree on what counts as a proof and so on. Instead of finding that, we find scientists disagreeing quite a bit about the significance of measurements. Some will say these measurements really seal the case for global warming. And some others will say, no, there are many assumptions that have been made in the course of interpreting these measurements, which are actually on rather shaky ground. That's the true logic of science, is a logic that depends a lot on these assumptions that philosophers call auxiliary assumptions, or sometimes auxiliary hypotheses. So assumptions that are not the theory that's being tested, and not the evidence that's testing the theory, but assumptions that are necessary in order to interpret what the evidence is saying about the theory. And we philosophers and historians and sociologists of science also find that scientific opinion about these assumptions varies a lot, and not just because often there isn't enough evidence to to nail down the truth of some and the falsehood of others. And so, in fact, although scientists are in a certain sense being logical, they're interpreting the evidence in the light of these auxiliary assumptions. They often reach different conclusions about the significance of the evidence. So the bottom line is that the logic of science is a lot more subjective, in the sense that it depends on the subjective opinions of particular scientists than the general public often take it to be. Now, that's not to exactly tell you what the logic is, but I think that's the most important thing about the logic of science that the world at large can know.
Is there any classification of sources? If so, what does it look like? How you can describe it?
As with the question about logic, that's a big question, and probably the most helpful kind of answer I can give is one that focuses in on what I take to be one of the most important distinctions, but not by any means the only distinction. So I think probably the distinction that's most important in science is the distinction between the official publications of record, things like journal articles, and some fields, conference papers are important too, which are subject to certain very strict controls, and then everything else. So when I say everything else, I'm including a popular book a scientist might write, or a television interview they might give, or an interview like this, a podcast interview, for example, a radio interview, anything like that, where they're speaking to the world at large, but also informal talks that scientists give to their own colleagues. So if I, as a scientist, I might give a talk in certain situations at a conference which is kind of off the record, as it were. I'm not presenting my research. I'm just talking in a broader way about the way science works, or about what we might expect in the future. Also, the way scientists talk about among themselves even more informally at a lab meeting, for example, or just after hearing a talk at a conference. So all of those things I've now listed, radio interviews, informal talks, just scientific chit chat. That's one kind of source of information about how scientists are thinking. And then there are the official sources. And the thing about the official sources, so the paradigm here is a paper published in a scientific journal, is that they're subject to first of all, to this a kind of a strict requirement that only empirical evidence should come into the argument. This is what I was talking about before. So no, for example, no philosophical considerations, no theological considerations. That's the rule that governs what's written in the journals. Meanwhile, it's fine for a scientist when they're not writing in a journal to say, write a popular book about how, science gives us evidence for the existence of God, as Francis Collins, who led the Human Genome Project, did a few years ago. So that's okay, as long as you stick to the rules in the journals when you're writing in the journals. At the same time, in the journals, there are certain prescriptions for the presentation of evidence, which are highly objective, the kind of rules for doing a statistical analysis and so on. And these require you to calculate various quantities. I guess probably the best known and the most common is calculating what's called the p-value when you're doing null hypothesis testing. I won't go on and on about that. I'm sure many of you people you'll be talking to or who see this interview will know what I'm talking about, though. But it's all very regimented. In spite of that regimentation, though, what I said earlier does apply. It doesn't. You can't look at those very carefully calculated numbers and see what the evidence is telling you about the theory. You have to bring in these additional assumptions, which typically are not there in the journal articles. They're in the scientists' heads. But if you want to find out what the scientists are really thinking, you need to ask them off the record. Okay, so that was a long answer, but there's one more thing I want to say to pull it all together and to illustrate how important this distinction is. If you just want to see what the evidence is and present it in as objective a way as possible, you go to the scientific journals. But if you want to know what kinds of assumptions being used to interpret that evidence, you can't go to the journals. You have to go to scientists in some other way. It might be a matter of talking to them in an interview like this, or even just in a private conversation over email or whatever. But without doing that, you won't get the complete picture of any particular scientist's thinking about what the evidence so far is showing us about whatever the ideas in question are, climate change or string theory or whatever.
How to distinguish a true source from a false one?
Well, that's right. This is exactly what we were just talking about. That's a very difficult problem well, maybe I should say it. On the one hand, if you're looking at the scientific journals, where you have a lot of scrutiny and a lot of many rules that need to be followed, then although you can't absolutely rely on anything ever, of course. There's mistakes in the journals. In the mathematics journals, there are proofs that have errors in them. Many proofs apparently have errors in them. And in the science journals, there'll be evidence that might be, as scientists sometimes say, cleaned up a little bit. Nevertheless, the journals are a relatively trustworthy source. For everything else, it's much more complicated. You have different, let's suppose all you're interested in is what scientists themselves say. So we're not even thinking about, say, reportage in newspapers or science magazines or online encyclopedias or anything like that, but just reading the books and watching interviews of scientists themselves. You will find disagreement because scientists have different views about what the evidence says about their theories because they have different assumptions. What you need to do, if you're really going to get to the bottom of that disagreement, is to find out what those assumptions are. Find out why it is that some particular scientist thinks a certain kind of measurement isn't as revealing as many other scientists take it to be. What is it that bothers them? And to do that requires an enormous amount of work, and it's not really reasonable to expect ordinary people to do that kind of work. So what we need is some kind of secondary layer of interpreters to do that work, and that's the sort of thing that a science reporter for a newspaper might do. Or in the case, I'll go back one more time to climate change, the sort of thing that the IPCC, the UN body that's set up to interpret the evidence about climate change, does for us. But in short, it's a difficult problem. On the whole, we can't do it ourselves unless we're dealing with some issue that we're intimately involved in. So we need to not just distinguish reliable sources in the science itself, but reliable sources about the science, using, I suppose, what people call practical wisdom.
Okay. Actually, what logic should a person use when searching, classifying, and selecting reliable sources of information?
Okay, this is good. This is again, this is just picking up exactly where we left off. So suppose you're interested in what's going on in the science of climate change, in the science of COVID, or for that matter, in the science of string theory or genetic engineering. So you're not a scientist yourself, you're not a philosopher of science, you have no particular educational background. How can you go about, where should you start in finding reliable sources? I think the answer for most people has to be is good, responsible science journalism. So you need to be able to find the kinds of places where the journalists are committed, I guess, have the kind of time to look into things in the context, to talk to scientists and do the kind of thing I'm talking about, look into the assumptions that are behind kind of conclusions people have. I don't think I have any special insight into how to recognize the best science journalism, although I think I can do it. But I do believe that's the right source for most people, unless, I mean, even I talked a few minutes ago about the UN body that interprets the results of the scientific work on climate change, and they issue reports which are readable by a regular person, but a regular person might not have time to read those reports. So they really need somebody else to read those reports for them and report. I suppose it's really the same. It's the very same issue that comes up with getting reliable information about anything complex. So about politics, about science. we need to somehow identify. We need quality journalism, and we need to be able to identify it when we see it.
How do you assess the expediency and the quality of scientific databases?
Oh, well, now I really am not an expert in those databases. So I would ask a friend who I think is an expert. I'm sorry, I can't give you a more helpful answer there.
Maybe you write some articles, maybe Web of Science or like this LCBR. You also have articles in this database, also, yeah?
I don't specifically have any real insight into the reliability of the databases. I guess I tend to trust them. I suppose that for someone like me, who's a philosopher of science, I'm embedded in this network of other philosophers of science and other scientists, where I have some confidence that I'll hear about problems that emerge. So I myself, I'm relying on the ecosystem in the same way that a regular person would rely on the ecosystem of good journalism. I'm relying on the ecosystem of my colleagues. But I have to admit myself, I don't have any specific checks or insight into this sort of thing. I'm relying on the effectiveness of the rumor mill, where the rumor mill is being run by people I trust. I think the same happens, by the way. So this is a little bit of a digression, but it's relevant to a lot of what we've been talking about. With scientific results generally, nobody can really, every scientist you talk to will say, well, some labs are more trustworthy than others. With some of them, that if they publish it, they probably did the experiments right, and there were no errors. In other labs, well, you never know. And so there's this knowledge that comes from long experience that scientists have about the work that's being done in their specialist areas, but only in their specialist areas. For the rest of us who, to some extent, rely on that work, what we need to do is put ourselves in a position where we hear that kind of chit chat. So where we're in the informal networks where people are talking about these things that they would never publish, they're very unlikely to say in public in any way, but certainly could never publish in a journal. So that's something somebody who's in a university network can do, because they have colleagues who are the specialists in question. It is the general public, of course, is one step removed from that.
Okay, my next question is, in your opinion, what impact do Wikipedia and other similar encyclopedias have on science and education? And why do you rate their quality, for example, Wikipedia articles?
Well, it varies a lot. Some of them are excellent, and some of them are not very reliable at all. In the sciences, I've seen very few that are not reliable. Some of them are rather unhelpful, and some of them are excellent. So I would say, on the whole, the system works pretty well. The Wikipedia's system of sort of peer review and so on, in terms of reliability, at least. A more common problem is that the articles are not very helpful to somebody who doesn't already know a lot about the field. They're written in too technical of a way and so on. But it does require, as we tell our students, it does require a certain kind of alertness. It's like walking down the streets of New York City in the old days when there was a lot of crime. You always have to be aware of what's going on around you, and aware that something may have gone horribly wrong. So it requires a kind of vigilance. Now, you asked me about the effect on science and education. for someone like me, actually, Wikipedia can be quite helpful. Now that's because I would never need Wikipedia in my own specialty, that is the philosophy of science, or in fact in any area of philosophy, because it doesn't go into enough detail and depth. That's simply not sophisticated enough. But because I'm a philosopher of science, I often need to know very quickly what's going on in some science that I know very little about. And there I do find it helpful. And as I say, as long as I maintain that vigilance, it's quite useful. And I encourage my students, now turning to education, to use it, but use it carefully. Of course, Wikipedia is not the only thing out there, but it's probably one of the best sources. So on the whole, I think it's a good thing, and I'm happy that it exists.
Do you want maybe something add? And perhaps I didn't ask you a question that would you like to draw your attention to?
Well, actually, those were good questions, and I think I talked about just about everything I was thinking is relevant to the topic of the conference.
Mm-hmm.
You know, it's a great topic. Obviously, it's very important now when well, we didn't talk so much about where the misinformation comes from, but maybe we all know the answer to that question. And in any case, that's not so much my particular specialty, but there is a lot of good information out there. You do have to understand its limits to be careful, and you have to have friends who may not be your personal friends, but they may be the science journalists, for example. You need some kinds of friends who can function as intermediaries between you and just the huge amount of that there is to know. I think that to somebody who's really genuinely, well, I feel like for someone like me, there is an enormous, there are many good sources out there that I can connect to very reliably. But it is very disturbing that people I know who are intelligent and interested in understanding what's going on in the world can be quite captured by poor or misleading sources, you know, typically internet-driven, that lead them astray. I don't know quite how to solve that problem, except to, as their friend, to talk them out of their prematurely forming opinions about these things.